Hello everyone, today we're going to dive into the chain rule. What is it and how can we visualize it? First I'm going to use Desmos, secondly Mira, then chain rule definition, and lastly you need to check the video about the slope formula, and before this video, video about the derivatives. If you are familiar with this, no need to check. Let's start. I'll close this because we don't need it anymore. So what is the definition of the chain rule? It says that it is a formula. It is the formula that expresses the derivative of the composition of the two differentiable functions f and g. So in other words, the chain rule says that if you have a function and inside this function there is another function, you need to take the derivative from that another function which is inside, and you need to take the derivative of the outer function. So this is what this formula expresses. So we take the derivative of the function outside, and then we take the derivative of the function inside, which is x. So let's actually dive into it. So I'm going to use Desmos. First we're going to change the color. I'm going to make it a black theme. Then label for x is going to be x and for y accordingly. Let's close it and let's create first two functions. So we're going to make a function which is going to be parabolic function. So it's going to be x in the power of 2. So we have this function right now, and then let's create another function which is going to be g of x is equal to x, and we might say it's going to be the same like x in the in the power of 2, but I'm going to a bit like make it a bit complicated, so I'm going to use in the power of 4. Okay, so now the question is, how can we make the function inside the function? So let's make it actually I'm going to take this function and I put it inside the function f of x. So how can I do it? How can I do this? This is the question, and the way how can I do this is to say g of x. Okay, so now what it says is this: f of x is equal to this function, and then x goes into this function. So it basically means that we have something like that right now. We have f, and then we have g, and then in g we have x and this. So this is yeah, right now it becomes another function because it's already inside the function f, but this is, let's just make it invisible. So it says that, well, we are going to get into the f function, and f function is going to receive the output of the g function. Okay, so going to into the f of x, we first go to the g of x, right? We don't exponentiate it because this is the function. First we need to get the output of the function and then exponentiate it. So we go into g of x, so means here, and then we take x in the fourth power, and then we get some result for any number which you prefer to use, and then we make this result in the exponent of 2 and get the final result. So this is basically it. Okay, hope it was helpful to explain. Now we have the function inside the function, and let's use the chain rule. So in order to use the chain rule, we need to be familiar with the derivatives. So the question here is, what is the derivative of g of x, and what is the derivative of f of x? Okay, now so what is our f of x? It's basically x in the power of 2, right? And what is our g of x? It's basically x in the power of 4. And the reason why I'm saying that this is the x in the power of 2 and not the x in the function g and then the power of 2 is because g becomes a number, and this number is basically our x. Okay, so this number, the output of the g of x, becomes our x. So our derivative of this is going to be out of the x of 2 in the power of 2. Okay, so I've explained already what is the derivative of f of the parabola. This is basically just simply, I mean, x of 2. This is basically simply 2 multiplied by x, which is perfectly correct. But we did not explore what is the a derivative of x of 4th, and we might say, well, probably the derivative of it is just simply x for x, but it's not correct. And the reason is because it is not that much simple. So we might, of course, some smart guys of you may say, now, well, it's going to be 3x and the power of 3. Now, I mean 4x and the power of 3, and you will be right. But the problem here is, well, we can just memorize the formulas, or we can explore it and get into our mind how actually we got this. And this is what I want exactly to do. So let's recall, using our mirror, let's recall what is our formula of of finding the derivative of the function. So let's say we have f of x, and of this f of x, we're going to take the derivative. So the derivative denotes as this dash before the brackets. So then we say that it is equal to first f, then x, and again, for those of you who are not familiar with this formula, please check my video with the derivatives, about the derivatives, so they are explored and visualized how it actually works at all. So minus f of x, and then over, we might say x plus h minus x, which is just simply h, okay? I don't want to rewrite it again. So now let's apply our function, which is, I mean, right now I want to clarify that x in the power of 4, the derivative of this is 4 multiplied by x, and the x of power of 3, okay? So, or x and cube. So let's clarify it. So we say that we have our f of derivative of x in the 4. So no, which is just this, okay? So then we go here, and what is our f of x? So this is x and this is x. This is the way how we can explain this is that probably we have 4 plus 2, and we have here 6. So f of 6 and f of 4 plus 2 is the same. We will get the same result. So this is basically just x, and this is basically just x. So we can say that this is just basically x. It's not, I mean, we might say that x plus h is in the variable x1, okay? So, and basically this is the same as f of x1 minus f of x. So we can just delete this one, and this will be just simply the same. If we understand this principle, we can go further and say that x plus h in the fourth power. So and the reason is because this is x. So what is our x? It's in the fourth power. So this is the reason why we do so. And then minus x in the fourth, because what is f of x? This is x in the fourth. The same thing applies here. We divide it over h, and now let's recall a bit calculus. Now we might use the formulas which will just simply short our time, but I'm going to do it pretty much explicitly. So I'm going to say this, then I'm going to copy this 4 times, okay? First, no, it doesn't work this way. Okay, first time, second time, third time, and the 4th time. Okay, so now we got our exploding. So this is basically this, and of course multiplication between them. Now we just add what we missed, x and the 4th, over h. Okay, of course I forget about the one pretty much important tool here, is that this basically is not just this formula. This is also should be applied with limit. I always forget about the limit. So now limit where h approaches to 0, and this is very important tool. So we need to always remember about this. Again, limit and then h approaches to 0, which means that h will be close, infinitely close to 0. And this is very important, so the same limit applies here. Okay, it will be a big curve, So h approaches to 0. Okay. So now the same thing will be applied here. Limit is h approaches to 0. And now let's explode it. So what is going to be this? So this is going to be x multiplied by x, and the second power. Then it's going to be multiplied by h. So we are going to get x multiplied by h. And then h is going to be multiplied by x, which is also h multiplied by x. And what we got from here and from here, actually the same thing. So we can say it is just 2 multiplied by x of x and h, and then h in the power of 2. So this will result to this. We have this, and then we say x multiply, of course, x squared multiplied by 2x h. Hope you are familiar with this. And then multiply by the h squared. So basically the same thing we will get if we will do the same operation with this. So I'm going to just copy this because this is basically the same thing. Command C and then Command V. Yeah, I'm using Mac. And then again over h and minus x and the fourth power. Okay. So here we are. So, and of course, limit h approaches to 0. So now we need to explode this, and will be a bit complicated, but let's do this. So first of all, x2 multiplied by x2 is going to, in the power of 2, is going to result x in the power of 4. And then, so we've made this. Now then x2 multiplied by 2xh is going to result as 2x squared h, so plus 2x squared h. Okay. Then we are going to multiply x2 by h2. Is going to result x2 multiplied by h2, x2 x squared h squared. I don't know why I say 2. This is just a bit simpler, but it's not correct. 2xh multiplied by x squared is going to result to, and of course I've made a mistake here, it's going to be x cubed, and the reason is because we multiply x squared by 2xh and there is already x, so it basically means that here is the 3 x's here, so it's going to result x 3. So, and the same thing will happen here. 2xh multiplied by x squared is going to result 2x cubed h. Okay. Basically what I want to do is just copy this, and yeah, probably for the sake of simplicity I'll just remove this and make it again. So where's my pencil? Pen. So 3. Okay. Then now just copy this, and then paste it somewhere here. So let's go back and make plus. So we've multiplied 2xh on the x squared. So now 2xh multiplied by 2xh is going to result simply 4x squared h squared. Is it? Let's check this out. Yeah, 2x squared and h squared. So 4. So plus 4 x squared and then h squared. So this is what multiplication between them will result to us. So 2xh multiplied by h2 is going to be simply 2xh squared. So plus 2xh, oh no, first x and then h squared. Okay. So now we're almost done. Now we need to multiply h2 on the x2. So we're going to result x squared h squared. So plus x squared and then h squared, and then plus plus the h2 on 2xh, which is going to result 2xh squared. So plus 2xh squared. Okay, now we got there. So and at the end is going to be h in the power of 4. So plus h in the power of 4 and then minus x4, which is was outside the scopes. So, and then this all very big equation just over h. So now let's find these similar parts here. So first I want to say that this one is similar to this one, and then I'm going to say that this one, I'll just put it so similar to this one. So this one cancels with this one. Then 2xh squared. Yeah, and this one is also similar to this one. So we got three similar ones. So this one, and this one. And then this, I'll put it as two lines, as similar to this. And lastly, this is not similar to any of them. So what I want to do is to say that this one plus this one is going to be 2x cubed h cubed. Oh no, 2x squared h squared, and then 2x squared h squared plus 4x squared and h squared is going to result 6 multiplied by x squared h squared. So it's going to result, first I want to put this, so 6, no, it's not 6, it's going to be 2. So 6 x 2 h, I mean x squared and h squared. Okay, so we get rid of this, I mean we just sum them. Now then we are interested in this one, so this one is going to result as basically 4 x cubed h. Okay, so yeah, isn't it? So yeah, 4x cubed h. So plus 4 x cubed, and of course I forgot about the limit again. This is my this is my weak part of my math. So limit is going to be here, and limit also is going to be here. This is much more easier for me to to do, because I don't want to write it every single time, you know. So, and then lastly, this is going to result 4x squared. So plus 4x, this is not y, it's x. Okay, h squared, yeah, h squared. Now, and then lastly plus h4, h in the power of 4, and then over h. And now the question is, how from this can we get this 4 multiplied by x in the power of 3? So, and to get this, what we need to do, we need to put out of the scopes some of the values, which is similar in all of them. So, and the similar value in all of them is h, like h consists here, h is here, h is here, and h is here. Although x is almost everywhere, x is not here, so here's no h multiplied by x. So this is the reason why we need to put it out of the scopes. So now what we get from this, well, it's too big, I think. Let's remove this and make it not so much big. Okay, now is equal to, let's write this limit, which I don't really like, but which is the essential for the derivatives. H approaches 0, then, well, it's the curve 0. Okay, a bit better. And what we do is we put h out of the scopes. So we say h, and then what is in the scopes? So now we got 1h from here. It means now we got 6 x squared h. Okay, 6 x squared x squared h. Okay, now then what we got from here is just simply 4x cubed. So plus 4x cubed, 4x cube. Okay, and what we got here is plus 4xh plus 4xh, and then from this just plus simply h cubed. So now I wanna explain what we did. So what we basically did is that we just took h from every of the components. So if we will now multiply this h here and here and here and here, we will get this. You see, so h multiplied by here is going to result 6x squared h squared, which was here. So x like 6x squared h squared, and the same thing here. So h multiplied by 4x cubed is going to result 4x cubed multiplied by h, what was here. So this is basically the basic calculus. I just explained it for the very probably like newbies, but anyways, I think most of you are familiar with this. So now we are going to cancel h and h. And say that again, limit. No, I'm going to copy this. I'm too tired from these limits. So limit approaches. Limit for h approaches 0. And at the end, you see, yeah, I'm going to copy this as well. I'm too lazy for like drawing this all again. Okay, so we got here. So we don't have this h here. Oh no, I wanted to copy this, but anyways, just imagine that this is still here. So what we got here is this. And again, what is the R condition? The condition is h approaches to 0. It basically means that 6x squared multiplied by h is simplified as 6x squared multiplied by 0. And what is it will result to us? Any number multiplied by 0 is going to result 0. So now we are multiplying 6 by 0 and x squared by 0. It is going to result as 0 or just nothing. So we can delete this part or cancel it. I mean, this part just vanishes because of the 0. So this part vanishes because of the h. What about this? This part vanishes because of the h, and this part vanishes just because it's h. And what we get at the end, and limit already doesn't need because we don't have an h. So 4x3. So what is it? Is it the same one? Yes, it's the same one. 4 multiplied by x and the power of 3. So congrats, we've made it. So this is too long, very long trail, yeah, or trial or train, whatever. So now we've explored how did we get this, and now let's dive back into the derivatives. So now knowing that x in the power of 4, the derivative of this is 4x cubed, and knowing that the derivative of x squared is just simply 2x, we can calculate the chain rule. So we're interesting in this. Now let me make it as a note. So we're interesting of f, then of g, and then of x. So first, knowing this rule that we need to find the derivative first of the inner function, and secondly of the function outside, or applying the same formula, but I would prefer this one. Now we first, again, what's our rule? First, calculate the derivative inside. So let's make it. What's the derivative here? So we're taking our x, and let's say that our x is equal to 0.5. That would be great. X1, for example, just for the sake of simplicity, or x100, doesn't matter. So 0.5, and let's calculate what's the derivative of this. So the derivative of this is going to be 4 multiplied by 0.5 and 0.5 and the power of 3. So let's calculate it. According to what we got from our calculations, this is 4x3. So now 4 multiplied, no, it's going to be like x, just multiplied by 0.5 and the power of 3, or 0.5 cubed. Remember from the basic calculus that first we do exponentiation, secondly we do the multiplication. Okay, so doing this, let's do. So 0.5 is going to be, of course we can do it like this. 0.5 is multiplied by 0.5 and then slash, and then 5 multiplied by 5 is 25. And what's the, no, don't go, okay, 25, and then we have 1 after the dot and second after the dot, so it's going to be 0.25 because we have 2 of them, so it's going to result 1 and then 2. So and 0.25 is just simply 0.5 squared, but we need to 0.5 cube. So we now multiply 0.25 on 0.5, of course you can go ahead and do this. 0.5, so we're going to get 25, which is 5 at the end, and 2 we keep in mind. So 5 multiplied by 2 is 10, and 10 plus 2 is 12, so it's going to result 1, 2, which is 125. So 3 symbols after the dot, it means that we're going to calculate 3, 1, 2, and 3. So it means that we got 0.125. So, and this is what it results to us. So now we have 0.125 multiplied by 4. And this, I'm not going to calculate this in such a way. I'm going to calculate it just simply like 4 multiplied by 100 is 400, and then 25 multiplied by 4 is just simply 100, so we got 0.5 from this. So we get 0.5, okay. So this is cool. So we get 0.5, and now what we have again, so our derivative for 0.5 is 0.5. This is silly, I know, but this is what we got. So for our derivative 0.5, for our point 0.5, the derivative of this is 0.5. Yeah, and I want to actually put the formula here. So we have this. It basically means that, again, this is the derivative, inner derivative. So we need to find inner derivative. So it basically means that we need to find 4x and the power of 3. And then finding the outer derivative, we're going to use all of that. So basically, outer derivatives takes the function which is inside it. So like basically, it means that our outer derivative takes the function inside. And the function inside give the output of an x. So it basically means that it's not going to take like f of x, it's not going to take the derivative of inner function, but it's going to take just inner function for itself. So knowing this, it means that we have, again, we have f, and what is f is just x squared. What is our x in this point? Our x is x and the fourth power, and the reason is because we goes first in this function, so we goes first in here. So it basically means that we have something like this. We have x in the fourth power, and then squared, and then multiplied. So they're multiplied, and this is basically what it is. Like if you look at here, you see that this is multiplication between them. And first we got the inner derivative, and then we were getting the outer derivative. But outer derivative takes as input the inner function. Okay, so like I hope you got it. So yeah, you see it takes it. Okay, this is pretty much cool. So what is our x in the fourth power? We calculated for 0.5. Like again, what is here? Instead of x, is going to be 0.5, and instead of x, here is going to be 0.5. So for this, we already got our result. We changed x on 0.5, and we got 0.5. So we can say right now we have something like that, like this. We have 0.5 in the power of 4. Of course, we can say that this is going to be all in the power of 8, but I don't want to do it for now for the sake of simplicity, and then multiplied by 0.5, because 0.5 is the result. This is now looks like 5. Because 0.5 is result of 4x and the power of 4x cubed. So now let's calculate 0.54 in the power of 4. So 0.5 multiplied by 0.5 is giving us 0.25, and then 0.25 multiplied by 0.5 is giving us 0.125, and then 125 multiplied by 0.5 we get in this the fourth power. So let's make it 0.125 multiplied by 0.5. So let's make it, that's so hard. 0.5. Let's zoom in a bit. So now we multiplied 5 by 5, so it's going to result as 5 because we keep the decimal part in our mind. So 5 by 5 is going to be 5, 5 by 2 is 10, 10 plus 2, which came from here is 12. So we get 2 here, and then 1 we keep in mind. So 5 multiplied by 1 is going to result 5, and 5 plus 1 is going to result 6. Okay, and now how many symbols after the dot? There are 6, like 1, 2, 3, and then 4. Oh yeah, 4, not 6. So we have 4, and we calculate 1, 2, 3, and then 4. It means that here is going to be 0, 0, and then dot. Okay, so now we get this. What we are going to do next we got this. So I'm going just simply to copy this. So we copy this, and we say that now instead of 0.5 in the power of 4, we have something like that, like this. Let's put it here. And then we say this. So is equal to brackets. Oh, it's not, looks like 5. Okay. Brackets. No, it's not model. It's bracket. Then I mean, it's not an absolute value. I mean, it looks like absolute value, but it's not an absolute value. In the squared, so this number squared, and then multiplied. This is not a 0, it's multiplication symbol. So multiplied by O. No, it's not 0.5. And then we're going to get the result, so our actual derivative. So let's raise it in the power of 2. So what we're going to do is now we're going to put it again here, and then we are going to say that we're going to multiply it by itself, which is going to be here, multiplied by itself. And now let's calculate. So 5 multiplied by 5 is going to result 25. All right, am I right in this? Yeah, I'm right. So 25, 5 here. What's going to happen then is 5 by 2 is going to result as simply it would be easier if we would just use to like 0.065 multiplied by 2, but anyways, let's do it so, because it's actually the same thing, but this one is harder. So 2 is going to be here, 5 multiplied by 6 is 30, and then plus 1 is 31. So we got 30, 1, 2, 5. Then we go here, 2 multiplied by 5 is 0, and then 2 multiplied by 2, 4, and which is going to be here, 4. 2 multiplied by 2, 4, and then plus 1. Wait. Got complicated. So 3, 1, 2, 5. Okay, now 2 by 5 is 0, because then 2 by 2 is 4, and plus 1 is 5. Okay, now it works. Then 2 multiplied by 6 is 12. Then 6 multiplied by 5 is 30, which is 0, and 3 we keep in mind. 6 by 2 is 12 plus 3, 15. So 1 keep in mind, 5. And 6 by 6, 36, and 37 because of 1, which we keep in mind. So this is 1, this is not anything else. So 5 goes here. 2 goes here. So 6 goes here. Then 3 plus 2, and then it's going to be 5, 10, 0, and then 9, and then 3. Well, something wrong is here. Well, I think I did something wrong with this. Now let's use the Desmos calculator, which is let's just go here, calculator, and let's calculate what is it actually. 0.0625 multiplied by 2 is 125. So I got pretty much bad result. No, I got it correctly, right? So Why does it cause the difference? Yeah, and the difference because it's, yeah, it causes the difference to us. So let's say this, and then let's say this is going to be multiplied by 0.5, and it's not correct at all. So what did I do wrong here? Of course. Guys, I hope you found this mistake. You see, I don't take the derivative from the inner function when I take the derivative from the outer function, but it is not derivative for the outer function. The derivative for outer function is 2x, but I took it as not the derivative, but as the function. So this is basically a mistake, and I'm thankful for to those guys who found this mistake already. So mistake, mistake, mistake. What is it shall be is this 2 multiplied by x4, then 2 multiplied by 0.5 and the power of 4, and then 2 multiplied by this. And now we get the correct result, because this was absolutely incorrect. Of course, it will result something like 0.0390625, which is absolutely what we do not need. So I want to remove all of that. Like it's just nonsense. So what we're going to do is this. We're going to multiply it just by 2. So we're going to multiply it by 2. So 2 by 5 is going to 1. 0, and then 1 in our mind. So 5, because 4 plus 1, and then 2 by 6 is going to be simply 12. So, and now calculate the signs. This is just simply, oh yeah, of course, 2, so many mistakes, sorry for that. So 2 shall be here, so 2, so because it's not the decimal part. So now 1, 2, 3, 4, and then 1, 2, 3, 4, and then 0 gonna be here, so we got 0.125. So we've basically made this part. So now 0.125 is going to be multiplied by 0.5, and let's make it just simply, so 0.5, which is just, we can calculate it as 125 multiplied by 5. So 5 multiplied by 100 is 500, and then 25 by 5 is 125. So 500 plus 125 is going to result 625, and 625 with all these numbers out there. So 1, 2, 3, 4. So it's going to be 1, 2, 3, and 4. So here's going to be 0, and then after this 0, it's going to be 0 dot. So now what we got is this. O, just a bit carefully, 0, 6, 2, 5. And basically this is how we found the derivative for this. And let's check this out right now. So we go in Desmos and we check this out if our derivative was correct. So Desmos by default will calculate the derivative. If we will take the derivative of f of x, it will behind the hood, we'll calculate the derivative of this and then multiply this derivative by the outer derivative. But I don't want to do it in such a way. So probably what I would do, now let's do it so, but you need to understand that Desmos does it under the hood. So what is going to result is, let's check this out, the derivative, which is dash, and then we take our x1, and as you can see, the result is exactly what we got here. No, so small. I thought it would be nice. Okay. So yeah, this is exactly what we got, 0.0625. And congrats, now you understand the basic principle of the chain rule, and soon we will dive into the neural networks. So for the neural networks, the basic knowledge which you need to have is first knowledge about the derivatives, secondly knowledge about the slope line, and then knowledge about the chain rule, and knowledge about the calculation of the derivatives and their short forms. Like all the time, you don't need to calculate it in such a way as I did. I did it just for the sake of simplicity. You see how many lines of like equations, but if you would just simply know like what is the power rule, you would say like if we have x4, this is basically what is the power rule. The power rule is this. So power rule says that whatever value will be in the exponent, so like if we have 4 and the, no, let's say x, and exponent is 8, the power rule says that the derivative of this is going to be 8 multiplied by x, 8 minus 1. So, and this is the derivative of the x and the 8th power. And basically, this is maybe like this. X and the power of u is equal to u multiplied by x and u minus 1, which is the derivative of x exponented with exponent u, so x and the power of u. So, and this is how it works. Hope this video was helpful. Check my profile, and if you're willing to support, you can check it in my profile and description. Thanks for that, and see ya.